Hi guys, this might be your very first time of seeing my face. My name is Faithful saying Day, and on this channel I teach everything students how to be smart with learning and life itself. So learn smart with Faithful saying Day. And in this very tutorial we're going to be treating sets and everything related with sets. But before we continue, I'd like you to know this. FNAB exams are quite different from whatever thing you've taught you in secondary school. Yeah, they are the same thing technically, but the way they will ask the question are quite different. FNAB exams are totally CBT, at least for the early stages in FNAB. So you need to tailor yourselves to learning how to answer CBT questions. You don't have to know all the workings. You don't have to know the long workings before getting the answer. So that's why I've devised shortcuts and teaching you the very things you need to learn to pass your exams. So without further ado, let's get into the tutorial. So guys, sets. Just like I said, you do not really need to know all the long calculations or types of sets or all those things. I'm just going to teach you exactly what you need for your exams. FNAB exam is quite different from secondary school, so I want you guys to first forget your secondary school stuffs. This is a new game entirely. Okay, sets. Now let's first know what sets are. Sets are collection of well-defined objects or elements. That means a bunch of keys, that's a set. A group of individuals, that's a set. Now let's understand set notations. And I believe you guys already know this. This shouldn't be a problem for you guys, but I'm just going to go over it in case. Now the universal set is all the elements that belong to that particular set. So if I say in a study in a study containing FUNAB students, the universal set there is the FUNAB student, the total number of students in FUNAB, whether you're a postgraduate, whether you're undergraduate, whether you're a PhD or anything. As long as you're a student in FUNAB, you belong to that set. So that's universal set. Every element that belong to that set. The second one is the null set. The null set is just a set that has no element at all. The complement of a set is the elements that you can find in the universal set but cannot find in that set. They are the complement of that set. All these things will clear out as time goes. Subsets of a set, just from the name subset, like a set that you can see in another set. Just like take for example now FUNAB, just like I said in the other example, in a study containing FUNAB students, we can see that as a universal set, right? But we can pick out some subsets even in that universal set, isn't it? We can say postgraduate, that's a subset. Undergraduate, that's a subset. Pre-degree, that's a subset. You get? So smaller sets in a set is a subset of a set. Element E, this thing that looks like E, it's called element, or sometimes referred to as belongs to. Element belongs to, that is element of a set, that is this belongs to this set. FUNAB student belongs to that universal set. All these things will clear out as time goes. Union of a set is just bringing together of all the elements of two sets or two or more sets, bringing together of all the elements. That's union of sets. Intersection of sets is the common element between two or more sets. What is common between them is the intersection. The difference is just like from the name, the difference of a set. What is in a set minus what is in another set. We have talked of complement. This delta, it's not something you guys really need. Let's forget that. Okay, so let's talk about numbers, types of numbers. Firstly, we have the natural number. Natural number is the number that we are all used to, the 1, 2, 3, and so on. Just the one we are used to. Whole numbers is still the same thing, except I start from 0. Now, integers had the negative side of numbers with it, so that means we have the positive integers and we have the negative integers. The only difference between integers and the other ones, because this one has the negative side with it. Now, rational numbers are numbers that can take values between any two discrete numbers. Like it can take values between any two whole numbers, like 1 point something, 2 points, 5 points. You can take any value between any two discrete numbers. And just like the notation is here, it is noted as P divided by Q, where P and Q are elements of integers and Q is not 0. So P and Q, so what you need to know is it can take values in any number. It can be point, it can be in fraction form and so on. Okay, now real numbers is just the father of them all. It encompasses everything. Everything is real numbers. Let's treat some questions. So here numbers 1 to 20, universal set. A are the even numbers, B set of odd numbers, C the prime numbers. So let's get them. Then that means universal set is 1 to 20. Set A, that should be the even numbers 2, 4, 6, 8, 10, 12, like that till 20. Then the odd numbers, set B should be the odd numbers there, and the prime numbers are the numbers that only one and itself can divide it. It can only be divided by one and itself, and that's 1, 2, 3, 5, 7, so on. And it should end at 19. 19 is part of them. It should end at 19. So now let's get this. What's A union B? A union B is just from the name union, the margin of elements of that two sets. So margin all the elements here, it should be what? 1, 2, 3, 4, 5, and so on till 20, right? So that should be the answer. We've matched the two sets together. Now what is A intersection B? The only thing they have in common, that's what? 2. A and C, the only thing they have in common is 2. So the answer there should be 2. B intersection C, what do they have in common? The things they have in common, that's 1, 3, 5, 7, 11, 13, 17, and 19. 19 should be part, because 19 is also a prime number. And A intersection B, they have nothing in common, so that's an empty set. Now A prime, just like we defined complement of a set, A prime or A complement is the numbers that you see in the universal set but cannot see in that set. So A prime or A complement here is the numbers that you find in the universal set but cannot find in that set. And what's that? You can see is 1, 3, 5, 7, 9, and so on. So the answer is that. They are the numbers that you can see in the universal set. We cannot see that. Now, A minus C. A minus C is A writing set A but removing everything that is set C from inside of it. That is set A minus elements of set C. And the only thing they have in common is 2. 2 is the only thing they have in common. So A minus 2. Remove 2 from the elements of A. So that's what it means, and that should be the answer. So it is still set A, but you remove the elements of set C from it. All those questions I've been treating are very simple. If you see this kind in exam, it means you are lucky, because this is not the type of thing you should expect in FUNAB exam. So now let's treat the kind of question you'd expect. X is an element of integer where x squared minus x minus 6 equals 0. Find x. Now x is an element of integer. That means the x that we're going to find here should be an element of integer. It should belong to an element of integers. That's the meaning. Now we need to solve for x first so that we can know what we are dealing with. And let's solve for x in that quadratic equation. And I want to believe that you guys still remember how to solve quadratic equation, right? If you don't still remember, you still be taught, but then this is a simple one, then you should still remember. So now let's try and solve this quadratic equation. So to solve this quadratic equation, coefficient of x here is what? -1, and the constant here is -6, right? Find two numbers that you multiply together to give you -6. You add or you subtract them, is going to give you -1. That should be -3 and 2, right? So -3 and +2 will be represented as x. In this case, x squared minus 3x plus 2x minus 6 equals 0. We now need to collect like terms. Let's find the things common here. The x is common to those two, so x in x squared is x in minus 3x is -3, plus 2 is common to those two sides. 2 in 2x is x, and 2 in -6 is -3 equals 0. So collect like terms. X squared plus 2, x plus 2x minus 3, then that means x is equals to -2 and x is 3. So now the decision, since they said x should be an element of integers, well, we can see that -2 and 3 are integers, right? They are part of integers. So your answer, x should be an element, x should be a set containing -2 and 3. What if the question is x should be an element of positive integers only? So that means it should be an element of only positive integers. So now we do the solving, but this time around the answer is still the same thing. The answer is -2 and 3, but -2 is not a positive integer, so the answer x is only 3. We can still do the same thing when x is negative integer. Well, since -2 is a negative integer, then the answer should be -2, since we are only including negative integers. Now, what if x is an element of natural number? Well, we know natural numbers are the numbers that we're used to, 1, 2, 3, 4, and so on. So the answer is still 3, right? Since 3 is the only natural number in the answer of this quadratic equation. Now let's try this. X is an element of rational numbers, where 2x squared minus 3x minus 2 equals 0. Find x. We know that it should be an element of rational numbers, right? That means you can take any value between any two discrete number and so on. It can be point, it can be anything. Now let's try and solve that quadratic equation. It has a constant. X squared has a value and that's a constant. If x squared has a value, you have to multiply the value of x squared with the coefficient of x squared with a constant. That should be -4. So find two numbers you multiply together to give you -4. You will add or you subtract them to give you -3. So that should be 4 and 1. Then let them represent x. So that becomes 2x squared plus x minus 4x minus 2 equals 0. And if you simplify it, you see that x in the first two is x in the first two. X out of that one is 2x left. X out of that one is 1 left. Then -2 is common there. -2 out of 4x is 2x. -2 out of 2 is 1. That's 0. So by the time you simplify, at the end of the day, you equate them to 0. You will get x equals to 2 and x equals to -half. Now, since they said x should be an element of integers, rational numbers, so 2 and -1 are rational numbers, -half are rational numbers, then the x equals to 2, -half. Try and solve it when the question is if x is an element of integers, and let me see your answer in the comment section. Now, Venn diagram. Let's try and solve a simple Venn diagram. In a class of 20 students, physics and chemistry are elective subjects. Students could choose to study them or not. However, 10 students study chemistry, 11 students study physics, 4 students study none. How many study both? So now let's first draw out the Venn diagram. Okay. First circle and the second circle, where the first circle is P for physics, second circle is C for chemistry. Now it is known that 11 students study physics, so let us put 11 there, and 10 students study chemistry, so let's put 10 there. Now 4 students study none. They are still in the universal set, but they are not inside the circles, so they will stay within the box. So the question now is find x. Find those that study both. Let's make that x. Now since p, inside this p, this value 11 and 10, we have those that study both. Why don't we subtract them so that we can know those that study purely chemistry and purely physics? So we have to subtract x from that numbers. So 11 minus x and 10 minus x. Okay, so that way we can know those that study purely physics, those that study both, and those that study purely chemistry, after you have subtracted those that study both from each of them. So now since we have known this, we can now say at the time we add up everything in this set, it should give us 20, which is the total number of students in that class. So adding up everything, we should have 11 minus x plus 11 minus x plus x plus 10 minus x plus 4 equals 20. So since we've added them up, now let's simplify. X minus x and plus x will cancel out each other there. That one's to turn to 0. So the answer should become 11 plus 10 plus 4 plus minus x equals 20. Add up all those ones, it becomes 25. Bring 25 to the other side, you get this. Then subtract it, you get minus x equals to minus 5. Minus cancel minus, you get 5. So we can say that x is 5, and if x is 5, that means the middle there is 5. The x that subtracts the two sides to 5, and that means we can say that those that study purely physics is 6, those that study purely chemistry is 5, those that study both 5 as well. We have gotten the answer. So that's how to solve a simple Venn diagram. And in order to keep this video very short, I'm going to stop here, and in the next video we're going to solve 3 Venn diagrams. Although you might not see that in exam, but for the sake of your manual, we're going to solve that. And any further questions that you meet in exam, we're going to treat it. And until I see you in the next one, peace.